Hello everyone, and welcome to today's show. Today is Saturday, August 22nd, 2026. Here I'm your host, San Noani. I'm so excited to be here with you today because I have a super interesting and trending article from the arXiv to share with you all. It is a bit technical, but I promise to make it fun and easy to understand. So let's dive right into it. The title of today's paper is SceneGTMM and Chemo Mapping-Based Scene-Where Transferable GNN Transformer Dual Graph Interaction Framework for Map Matching. The URL is https://.org/b/2608.19298. That is long, but do not worry. I am here to break it all down for you. So first of all, what in your world is map matching? Imagine you are using a navigation app on your phone, and your GPS says you are floating in the middle of a river, even though you're clearly driving on a road next to it. That happens because GPS signals can be noisy and inaccurate. Map matching is the super smart technology that takes those messy GPS points and snaps them onto the correct roads on a digital map. It figures out the most likely path you are actually traveling on. But here's the big problem that this paper is trying to solve. Traditionally, we used simple rules like finding the closest road. But that gets super confused if roads overlap, or if you are in a dense city with tall buildings. People started using deep learning, like transformers, which are great at looking at the big picture of your whole trip. But those deep learning models have a huge flaw. They're like black boxes, meaning we cannot understand how they make decisions. And worse, if you train the AI on the roads of Beijing, it completely forgets how to work if you take it to Guangzhou. It is bound to the specific map it was trained on, which means it cannot handle new cities or dynamic road updates. That is right. This is where SceneGTMM comes in as a total superhero. The researchers created a framework with 3 mind-blowing innovations to solve these exact problems. First, they use something called a mapping scene relative strategy. Instead of memorizing the world map, the AI builds a little local bubble around your trajectory and turns the map into a relative coordinate system. By mapping the roads onto a unit disk, the AI stops caring about exact GPS coordinates and starts looking at the shapes and angles of the roads. This means you can train it in one city, and it will perfectly understand the roads in a completely different city. The second big innovation is the Transformer Dual Graph Interaction. Basically, they use a graph neural network to understand the local connections of the roads, like intersections and speed limits. At the same time, they use a transformer to look at the global timeline of your trip, figuring out your overall path preferences. By making these two systems talk to each other, the model can suppress bad GPS noise and perfectly align your movement with the road network. It is like having a local guide and a helicopter pilot working together. And the third part is that enhanced structured prediction. PERF stands for conditional random fields. While the transformer is great at guessing where you are, it sometimes suggests illegal moves, like jumping across a river without a bridge. The map acts like a strict traffic cop, making sure that the predicted path actually connects properly. Together, this framework achieved over an 80% accuracy, even when the GPS error was up to 15 meters off. That is a massive improvement over older technologies. When we compare this to other technologies, the difference is actually night and day. Older methods like hidden Markov models need humans to manually design the rules, and they fail when the GPS noise gets too unpredictable. Other deep learning models like Treasure arXiv are super accurate in the hometowns, but that totally crash when we try to transfer them to a new city. SceneGTMM is the only deep learning model out there that gives you top-tier accuracy and can pack its bags and work flawlessly in a brand new region without retraining. Now let us talk about how this amazing technology applies to our everyday lives. I have 3 specific application examples for you to show just how impactful this is. First, think about our daily navigation apps, like Google Maps or Apple Maps. Have you ever driven through a downtown area with massive skyscrapers? And your GPS just loses its mind? Your car icon starts spinning. And the app tells you to take a U-turn on a highway. With SceneGTMM, navigation apps can become incredibly robust against this kind of multipath noise. Because the AI uses the dual graph system, it can look at your past trajectory, understand the local road shapes, and accurately predict that you are still on the main avenue. Even if your GPS says you are inside a coffee shop, this means less getting lost and a much smoother driving experience for everyone. Second, this is a total game changer for the autonomous driving industry. Self-driving cars need high-precision maps to operate safely. But right now, if a car company wants to expand to a new city, they have to spend tons of time and money training their AI on a specific city road network. And with the Transferable mapping strategy in SceneGTMM, the autonomous vehicle brain becomes transferable. A self-driving car trained in Tokyo could be shipped to Osaka and immediately understand how to snap its position to the local roads. It understands the relative geometry of intersections, rather than memorizing absolute coordinates. This will drastically speed up the deployment of safe self-driving cars across the country. Third, it has massive potential for smart city traffic management. City planners use data from delivery trucks, taxis, and our phones to figure out where traffic jams happen and how to plan better roads. Well, a lot of this data is sparse, meaning the GPS points are taken very far apart, like every 60 meters. Old algorithms just draw straight lines through buildings where data is missing. But SceneGTMM is so smart that it can reconstruct the exact path a taxi took, even with huge gaps in the data. By understanding human driving preferences and road connectivity, city governments can use this to get a crystal clear picture of real-time traffic flows, helping them adjust traffic lights down early and completely reducing urban congestion. It is just so cool to see how math concepts, like conformal mapping, which usually just sit in complex analysis textbooks, are being used to solve real-world AI problems. By combining heavy math with graph networks and transformers, these researchers have built something truly robust and understandable. And they even made the AI explain itself by visualizing the attention weights, so engineers can actually see why the AI chose a specific road. Technology like this is the hidden bridge between our messy physical world and the perfect digital systems we rely on. I am definitely keeping an eye on how map matching evolves in the future. Well, that is all the time we have for today. I hope you enjoyed learning about this super cool AI framework with me. This is SceneGTMM signing off. Have a fantastic weekend, everyone. We will catch you on the next show.